So good morning, good afternoon, and good evening, everyone, and welcome to the second JAMS International Seminar, Unmanned Vessel and Coastguard Operations. My name is Kawai Jun, a coordinator of this seminar and director of the London Research Office of Japan Association Marine Safety. As for my background, I have served in the Japan Coast Guard for around a quarter century. Next slide, please. Next slide, please. So the questions are, how will the maritime domain change with the coexisting of unmanned and conventional vessels? How should Coast Guard prepare, respond, and contribute to these challenges ahead as frontline actor? In this context, last year, this open platform was established to explore the interaction between the advancement of the MAS and Coast Guard. This year, building upon the insight from last year, covers 4 topics. The 1, the safety of navigation. 2, search and rescue. 3, maritime law enforcement. And 4, the utilization by Coast Guard. Although the title refers Coast Guard, this seminar is not limited to the participants from Coast Guard only. I believe the comprehensive discussion on the future comprehensive discussion on the future maritime domain can only happen when all stakeholders come together. I'd like to express my sincere gratitude to all speakers who are contributing to this seminar, and special. I'd like to give special thanks to the Nippon Foundation for their support. I hope all attendees in this seminar will find, share, and bring back the valuable ideas and insights to address new challenges to contribute to their respective fields. Next, please. So now I'll move on to the housekeeping issues. We have 16 speakers for 2 days with more than 450 registrations participants from over 40 countries. And it will also be recorded and will make the video and presentation available after the seminar. I hope this is acceptable to everyone. If not, then you are, of course, free to opt out this seminar. The language is mainly in English and Japanese with interpretation. So speakers are invited to speak slower than normal. If you have questions at any point, please put your questions Q&A functions. And the raise hand function is not in use. The attendees here in London, please raise your hand and the staff will give you a microphone. Okay, so next, please. And today, we have opening remarks, 2 keynote speeches, and 2 panels, safety of navigation and search and rescue. The second day, tomorrow, has another 2 panels, MLE and utilization by Coast Guard. Next, please. Having said that, it's time to invite opening remarks. It's my honor to introduce the first speaker, Mr. Kida Satoshi, from the Nippon Foundation. He serves as the Senior Program Director for Ocean Affairs and will touch upon the Meguri 2040 project led by the Nippon Foundation. So I give the floor to Kida-san from Tokyo.
Good morning, good afternoon, and good evening. My name is Satoshi Kida, the Senior Program Director of the Ocean Affairs Department of the Nippon Foundation. I'd like to take this opportunity to express my sincere appreciation to the Japan Association of Marine Safety and all of you for your participation. Thank you. First of all, I'd like to briefly share the history of our foundation and some of our most recent activities. Our foundation was established after World War II with the aim of reviving the shipbuilding industry in Japan. We especially focus on supporting small and medium-sized shipbuilders. Through these efforts, we built relationships with various stakeholders in the Japanese maritime industry for almost 60 years. Most recently, we launched the Ocean Innovation Consortium in 2016 to promote the maritime industry and develop human resources in this field, such as offshore wind power generation, new vessels to reduce carbon emission, and other new technologies to respond to today's societal challenges. As all of you here may very well be aware, today, the issues surrounding the oceans are complex and diverse. And in Japan, we are facing a rapid decline in population. We need more people to support maritime and transportation industries, but it is getting increasingly difficult to do so. In Japan, about 40% of domestic cargo transport is coastal shipping, but the industry is struggling to maintain sufficient staffing levels. For this reason, in 2019, we started the fully autonomous ships project called Megiri 2040. In 2021, we successfully completed a test demonstration at sea. We are aiming to navigate at a fully operational level by 2025. The goal of this project is to reduce the number of maritime accidents caused by human factors and to address the shortage of seafarers. These issues are also very relevant to those who are trying to protect the safety of our oceans. UK and Japan have similar qualities on issues concerning the ocean. We are an island country with a long coastline. The total length of coastline in Japan is approximately 30,000 kilometers. It is the sixth longest in the world. Meanwhile, the number of personnel of the Japan Coast Guard is about 14,000. So we have to cover 30,000 kilometers of coastline with only 14,000 people. At the same time, the Japan Coast Guard must cover an exclusive economic zone the size of roughly 430,000 square kilometers. From this perspective, we think that the technology of unmanned vessels could also be useful in protecting maritime safety, not only in Japan, but all over the countries that face the labor shortage problem. Last year, the Nippon Foundation and the Japan Coast Guard hosted the Coast Guard Global Summit. We invited the heads of Coast Guards agencies from around the world to Japan. I'd like to show some presentation slides that we have used. This slide, in Japan, about 80% of maritime accidents are caused by human errors. So if we use this technology effectively, it may lead to reduce the number of accidents. Next slide, please. We have already successfully demonstrated tests in 2022, and currently we are working on some technological issues. Next slide, please. First, autonomous navigation in congested waters. Second, automated berthing. Third, simultaneous remote support of multiple ships. And fourth, more stable ship to shore communications. Next slide, please. The Nippon Foundation presented the following 3 points at the meeting as key benefits of deploying unmanned vessels to enable Coast Guard to operate more efficiently. First, maritime accident prevention. Second, safe navigation. Third, reduced workload. If we use this technology effectively, it may lead to reduced numbers of accidents. Furthermore, by leaving the vessel's navigation to automated operation, Coastguards would be able to focus on their core mission. We cannot escape the stark reality to having to secure our borders with fewer people. However, we believe that if we could use new technology wisely, we may be able to achieve effective maritime safety. I'd like to pay tribute to all of you who are working day and night to secure safe navigation at sea, and it would make me happy if any of what I shared today were interested and maybe even useful to you all. In closing, I'd like to express my hope for many fruitful discussions in today's webinar. Thank you.
Thank you very much, Kida-san, for the very important presentation and strong message to the Coast Guard. Thank you very much. And I'd like to introduce the first keynote speaker, Mr. Yamada Hiroyuki. Next slide. Yeah. Yes. So, Director of Maritime Safety Division of IMO. Unfortunately, he has another commitment today. So he gave us a video speech. He will talk about IMO's work for the mass code. So let's have a watch the video.
Thank you very much for inviting me to that JAMS London's the symposium on unmanned ship. And at first, I'd like to make a brief introduction. And IMO has been considering issues related to unmanned vessels, the agenda item on maritime autonomous surface ships, MAS, at Maritime Safety Committee, MSC. MAS is one of the important agenda items at IMO, since they will impact future shipping in wide areas, including safety, seafarers' role, shore-based facilities, etc. IMO is a UN agency responsible for maritime safety, security, and marine environment. And there are two technical divisions, a Maritime Safety Division, MSD, and Marine Environment Division, MED. I joined IMO in 2005 as a technical officer in MSD and oversaw technical matters, the carriage of cargoes and operational safety, including human element. In 2018, I moved to MED to deal with environmental issues, particularly reduction of GHG emissions from international shipping. I came back to MSD in the beginning of this year under the leadership of the new Secretary General, Mr. Arsenio Dominguez. Due to 6 years absence in safety matters, I learned quickly about mass issues at IMO for this seminar. So please allow for any mistakes I may make. Next, please. The first, the regulatory scoping exercise. It's a bit long name, abbreviated as RSE. At IMO, to address maritime autonomous surface ships, MAS, the Maritime Safety Committee, MSC, conducted the so-called regulatory scoping exercise, RSE, from 2018. The objective of the RSE on MAS was to assess the existing regulations, examining the extent to which IMO's regulations could apply to future MAS and their operations. MSC issued its outcome of RSE in a circular letter in 2021, providing the basis for drafting a non-mandatory MAS code. Next, please. The RSE defines 4 degrees of autonomy as you may know, but for recollection, first degree 1 ship with automated processes and decision support, and seafarers are on board to operate and control shipboard systems and functions. And degree 2, remotely controlled ship with seafarers on board. The ship is controlled and operated from a remote control center, ROC. And degree 3, remotely controlled ship without seafarers on board. And finally, degree 4, fully automated the ship. So unmanned vessels might be relevant to degree 3 and 4. Next, please. The RSE describes high priority instruments, and MSC assessed the applicability of mass against the following mandatory instruments, depending on their level of autonomy, degrees 1 to 4. SOLAS chapters, colleague, STCW, STCWF, load line convention, SAR convention, tonnage convention, and other mandatory codes under SOLAS. Next, please. RSE contains options for instruments to address mass operations. MSC analyzed and indicates options for the instruments on how to deal with these regulations depending on each level of mass. That there are 4 options, and option 1 is to use equivalencies as provided for by the instruments or developing the interpretations. Second option is amending existing instruments, and the third one is developing a new instrument, and the fourth one is none of the above, which means no need to change the instruments or not applicable. Next. This is a result of RSE in a matrix table. This is just an example for SOLAS chapter 3. If you see the left hand, that the column, this shows the degree of autonomy. If it's degree 1 mass ship, which means the seafarers will control the ship, then the options for that instrument is option 4. That means no need to change. And if it's a degree 2, which means the remote controlled, but seafarers on board, in this case, the options for this chapter, SOLAS chapter 3, would be the 1, 2, or 3, which means there may be the need for changes for the regulations. And if it's degree 3 or 4, which means unmanned ship, in that case, the option would be 3. That means we need a new instrument. I skip for further details in that the remaining columns. Next, please. And this is a summary matrix table for each instrument, depending on the levels of autonomy with options, as I mentioned, 1 to 4. There's a list of SOLAS chapters and other instruments. For instance, in the middle of the line, the STCW is mentioned, and if it's degree 1 or level 1 of autonomy, then there may be some need for some changes. And if it's a degree 2 or 3 for the autonomy, then some changes or a new instrument may be needed. But If it's a degree 4 fully autonomous ship, then it can be that this whole STCW may not be applicable. So this is an interesting result, and I skip for further details. And next, please. And now IMO is preparing a draft mass code. The mass code is goal-based, which means the tiers with goals, functional requirements, and regulations, etc. And this is a non-mandatory code. According to the current roadmap, the adoption of the non-mandatory mass code is 2024. So this year, end of this year, December is expected for effective from next year. So this is a very ambitious plan at IMO. The mass code is a complement or supplement to SOLAS, meaning the adding requirements related to automation provisions, cyber security, redundancies, remote operations, and others. And currently, this draft mass code would be applicable to cargo ships only with 500 gross tonnage and above. Next. And in this mass code, draft mass code, with regard to the application of the STCW convention, the first one that when seafarers on a mass, STCW applies to those seafarers. And when number two, when remote operators and masters at ROC, Remote Operation Center, and they are not on board a ship, STCW does not apply. The third, the mass code will address training, certification, and competency requirements of STCW as a basis. Number four, certain principles such as watchkeeping in STCW, when autonomy and remote operation should also be addressed in the mass code. This is some the contents of the current draft mass code. Next. And IMO is there. At IMO, there is a joint MSC leg file working group, joint working group on mass. Leg is that legal committee and FAL is facilitation committee. So this is a joint working group. This mass joint working group is a cross-cutting mechanism to address common priority issues identified by the RSE, regulatory the scoping exercise, such as human master who may not be on board is responsible for mass regardless of mode of operation or degree of autonomy. And the master of mass should have the means to intervene when necessary, and several masters could be responsible for a mass ship on a single voyage, but only a single master at a time. Also, legal issues such as UNCLOS articles are also that should be addressed. Next, please. This is the final one. The issues that may be related to Coastguards, though the number of mass will not be so large in the foreseeable future, mass will operate side by side with conventional ships, possibly changing their mode of operation during a single voyage, which might cause complexity. And even degree 3 or 4 mass, this means the unmanned ships, there could be seafarers on board in reality to safeguard safety, etc. for any reasons. And shore-based regimes and infrastructure such as ports, VTS, ROC should be established to address mass. The roles of Coast Guards, including AMSA operations, would be more important, particularly when mass emerge and increase, I think. And thank you very much. This is the final the slide for me. And thank you very much for that inviting me again. And I'm sorry that I cannot attend in person. Thank you very much.
Because roles and the message, if I can pick up the role of Coast Guard would be more important, particularly when mass emerge and increases. So that's a strong message. And we will talk about that issues in these 2 days, I believe. And sorry about the housekeeping issues, but if you use the Wi-Fi here in London, Japan House, so please use the Japan House public Wi-Fi, and put your email, and you can join the Wi-Fi. And if you just give him there are 2 pillars. So if you give the way to to the center, thank you very much. Okay, so now next I'd like to invite Professor Dr. Kevin Jones from the University of Plymouth. His speech is cybersecurity and unmanned operations. Doctor, please come at the front and please welcome Dr. Kevin.
Thank you very much. So good morning, everyone. Morning, afternoon, or evening, depending where you are. As we just said, I'm Professor Kevin Jones. I'm Deputy Vice Chancellor, Research and Innovation at the University of Plymouth. I'm also the founder of our Maritime Cyber Threats Research Group. Now, I'm honored to be able to talk to you today about the topic of maritime cybersecurity and some of the related issues that affect us now and will affect us sort of as we move into the autonomous space. Now, this is an area we've actually been working in for many years. And we've worked with organizations throughout the world, including quite a number in Japan. So I think it gives us a good perspective on this problem. And what I'm hoping to do is by the end of the next 15 minutes, I'll give you a bit more information about why I believe this area is of critical importance. It affects security and obviously safety in the maritime domain, but also the future profitability, I think, of those operating within this sector. Right, I'm now going to try and see if I can get slides to work. Okay, so we can go forward and again, please. Forward again. Okay, so cyber threats are common everyday issue. We're all sort of faced with them daily in our sort of normal life. Usually people assume it's an IT problem. And in particular, we'll say the shipping sector does tend to say ransomware, phishing emails, those kind of things. It's an IT problem. Banking has very good cybersecurity, and there are good policies, procedures, and practices. For shipping, it's a little bit different. We perhaps have not quite got to terms with all of the issues we're dealing with. In particular, when we're dealing with cyber physical systems, computer systems controlling physical devices, and potential real world damage. So if we can have the next slide, please. So what I'm going to try and do is to illustrate a little bit what the problems look like in our sector. I'll talk about 2 scenarios which are quite different in a number of ways. The sector is now becoming mature enough that we're actually understanding how to make money out of cybercrime in the shipping sector. Some of that involves pure money. Some of it actually involves physical damage and so affects health and safety. So the 2 scenarios I'm going to show you are intended to make you think in a particular way. Each of these stages has actually been checked against standard operating procedures within the sector, and also, I will say, on real hardware. So this is not me imagining something that might be able to happen. We've tried it on real hardware to ensure that it works. I will leave some details out since this is a public presentation, and I don't particularly want anybody going and trying it just to see if it works. But the Cyber Ship Lab team at Plymouth have been involved in developing these scenarios, and our aim is to make sure that they are realistic and possible. We do need to be aware that in the global maritime space, we have to be aware not just of crime, but also things like cyber terrorism and so on. And I think that when we get to the end of this, I will hopefully have convinced you it is not just an IT department problem, and it is very much more an operational issue, particularly as we look forward to what was just presented by the previous speaker, looking at issues involving sort of mass. Okay, next slide, please. Right, so first of all, I'm going to look at something that sort of we'll call classic cybercrime. So next. So let's imagine a particular vessel. This is actually a real vessel, but obviously, again, details are elided. So this is a large cruise ship, luxury cruise liner, lots of passengers on board, long voyage, 2 to 3 weeks, very modern vessel, lots of technology, ranging from passenger entertainment systems through to the latest integrated bridge and everything that goes along with that. The other thing about this vessel is quite interesting, of course, is much of the control systems are what we call fly-by-wire. In other words, there's no physical connection between the control on the bridge and a control in the engine room. So all of the information for this vessel, whether it's sort of how much money the partner has spent in the casino or how much of a rudder angle the sort of helmsman wants to set, those are all information going over the network. There are many existing standards, particularly around things like physical security. Passengers stay in the right bit of the ship. There are also advanced protection on the vessel from a cyber point of view, things like segregated networks and so on. Now, imagine what would happen if you were the master of a vessel like this. Just as you're sort of getting close to port, many of the systems on board the ship, both from a passenger point of view or from a cruise point of view, next slide, please, put up something like this. Your files have been encrypted, you have no access to anything. The only way you get access is by paying a Bitcoin reward. Not uncommon, many of you may have seen this in real life. The difference here is, while this is a classic cybercrime attack, in this particular scenario, there's a difference. You've not only lost access to your data, you've actually lost access to control of the vessel. So if we think about the safety implications of the crew on the bridge, now having no ability to affect what's going on in various other systems. Now, fairly obviously, there would be physical interventions in a manned ship to physically drop anchor, physically sort of turn the engine off. Just think for a moment about when we get into the mass space, what that would mean. Now, why does this happen? Next message, please. Next slide, please. So if you think about it, this cruise ship invites a large number of people on board into its physical environment where they stay for a long time with access physically to systems on board the ship. So if you were trying to do this from the outside, you'd have to find a channel in, you'd have to find various mechanisms for bypassing protections. A malicious actor here is on board for weeks. Now, I'm prepared to actually bet that any cyber criminal with a reasonable, next slide please, with a reasonable amount of skill, if left in an environment for that length of time, will be able to compromise systems. Not might be able to, will be able to. Those interested in details, I'm happy to talk after and tell you how we do it, but that is possible. What are the consequences of such an attack? Well, from a port perspective, relatively minor. You have a vessel not fully under command, possibly sitting somewhere where you prefer it not to be. You have to sort of tug it into a safe berth. Maybe there's long-term disruption. Cruise terminals tend to be scheduled quite tightly. You've got issues with passengers sort of not able to get off the ship, not able to get on the ship. It gets quite messy. For the ship, they've got disruption to key systems during a relatively high-risk operation at a bad time. From passenger point of view, they're pretty grumpy and pretty unhappy. So the consequences of this kind of attack may be fairly serious. But let's look at another situation, because this was a fairly standard cyber attack. It just happened to be on board a ship, which introduces no consequences. Okay, next, please. So here's an attack very specific to the shipping sector and with increasing consequences. Next. Right, we're looking at LNG tanker. Again, I won't name the specific vessel, but we did look at the actual systems for this vessel. Next. Now, so this is a relatively old vessel performing a regular mission. We picked an example. We picked Milford Haven because it's a port we happen to know, and it has some of the characteristics we want to explore. We could do it for any other port. This one happens to be interesting. Milford Haven has property of having some resources that are very, shall we say, volatile. It's the largest LNG terminal in Europe. Now, normally, next slide, please. A tanker approaching the berth would follow a prescribed route with appropriate procedures for pilotage, tagging, and so on, to eventually take its berth at the terminal to have its cargo offloaded. Next, please. Now, in this scenario, malicious attackers choose to intervene. There are various reasons why they may choose to do that, and I can explain them if you wish, but we're a bit short on time, so I'll plow through. We're just going to focus on the actual attack and what happens. So next slide, please. As the vessel sort of progresses towards port, at a certain point, the crew loses control of the vessel. They basically lose control of both throttle and steering. The vessel then takes an unintended course, which basically causes it to collide, either with the terminal itself or with other vessels docked at the terminal. Obviously, this leads to quite significant damage. Next slide, please. And what's actually happened here is an attacker has remotely accessed a pre-prepared attack, which at a certain point in its journey is triggered, and that triggering causes control of both rudder and throttle to be amended so that we get a collision. Well, at this point, sort of you might say, well, could this actually happen? Next slide, please. Could this actually happen? So we've played out this hypothetical scenario where a large-scale terrorist organization wishing to make a point does a supply chain attack. So basically plants the malware on board the vessel much earlier in the system, triggered by reaching a certain location at a certain interval of time. Now, this is not the kind of attack that any IT security is going to find. It's not the kind of attack that can be prevented once it's triggered. So what do these examples tell us? They actually tell us that we've got a range of potential problems in the maritime domain. Some are fairly classic, and standard cybersecurity mechanisms will help prevent. Others are very domain specific, and the consequences are also domain specific. So next slide, please. Oops. Right. So the first attack we looked at was pretty much a classic cyber attack. The way that attack would have been performed was using techniques like sniffing, brute force, getting privilege escalation, having found access to the network. It's familiar, but unusually we have people on board the vessel for long periods of time, day and night, which gives opportunities to cause such attacks. Some of the devices on board the vessel are maritime specific. Some of those are weak because they were designed to perform particular operations, not to be cyber secure. The second attack, next slide, please. This is much more specific to the sector. It's a supply chain attack using very advanced techniques. There are many reasons why one may wish to do this. Let's say terrorism. There are others we could talk about. It requires significant resource, but because of the maritime sector, small-scale manufacturers, you often know which device is going to which vessel because of the way refits work. A long supply chain with off-the-shelf components novel triggering conditions because of locality. Now, there are many mitigations that we could introduce to this, but it is a bit harder to mitigate this. Next slide, please. So kind of wrapping that up, next. Hopefully, these examples have made you think just a little bit differently about cyber in this domain, and it isn't an IT problem. The consequences of cyber physical attacks can be very serious, and it's an issue that's shared between operators, equipment manufacturers, ports, and also legislative approaches. The consequences of cyber attacks are very serious. The range of attackers is very large. So to address these problems, we need a very concerted effort based on awareness. And as was mentioned in the previous talk, the IMO are addressing both cyber in general and cyber in the context of mass. But everything from training, both for novel approaches and for traditional approaches, need to be looked at seriously. So maritime cyber is an existent but growing threat, which will only become more serious when you can't come back to me and say, yeah, but the master would look out the window and fix it. So these problems will grow. So I hope some of that was useful. I actually hope slightly concerning in some ways, because concern will lead to action. We're, of course, very willing to help with any of this. This is the kind of thing we actively research in. And I think it does rely on regulation, training, equipment, and everything as a holistic approach to basically make maritime cyber a beneficial technology, not a problem. I'd be happy to answer questions, certainly on the panel later. Thank you very much.